Yo. Yeah. I'm getting all pumped up. All right, so am I doing? Oh yeah. All right, so I'm gonna be going through. I don't even know how much I'm gonna do. I just know I'm gonna do a lot because I need to learn faster. So we're gonna start putting more work daily. Okay. So let's just get started. Catch a breath real quick. All right. So 1.5 is just an audio stream, character output, character input, and inline characters. In this lesson, we'll talk about standard output. Kind of the fuck. The input/output library. The input/output library, IO library, is part of the C++ standard library that deals with basic input and output. We use the functionality in this library to get input from the keyboard and output data to the console. The IO part of the IO stream stands for input/output. To use the functionality defined within the IO stream library, we need to include the IO stream header at the top of any code file that uses the content to define an IO stream, like so. Hashtag include IO stream. Okay, this is what is including it. Standard character output. The IO stream library contains a few predefined variables for us to use. One of the most useful is standard character output, which allows us to send data to the console to be printed as text. Character out stands for character output. As a reminder, here's our hello world program. Hashtag include IO stream for standard character output. Int main function. Within the block, we have standard character output hello world, which is a string. Printing hello world to the console, then we return 0 for our integer. Okay, in this program we have included IO streams so that we have access to standard character output. Inside our main function we use standard character output along with the insertion operator, which is these. I didn't know it was called the insertion operator. I thought it was the input operator. But yeah, insertion, I guess that makes sense. So the insertion operators to send the text hello world to the console to be printed. Standard character output can not only be not input. Sorry, I thought this was the output operators. Input operators would be for standard character input. Standard character output can not only print text, but it can also print numbers. Standard character output, integer 4, prints 4 to the console. It also be used to print the value of variables. So we declare the variable x, we define it with the value of 5. And then we output the variable x and return 0. It will produce whatever values within that variable. To print more than one thing on the same line, the insertion operator can be used multiple times in a single statement to concatenate, link together multiple pieces of output. For example, standard character output, insertion operators, hello, okay. Prints hello world. Here's another example where we print both text and value of a variable in the same statement. Integer main, int x, value of 5, x is equal to, and then the insertion operator is x, return 0, it'll then say x is equal to 5. Related constant, we discuss what the standard prefix actually does in lesson 2.9, naming collisions and introduction to namespaces. Using standard inline to output a new line, what would you expect this program to print? Standard character output, hi, my name is Alex. So there's no inline character or new line character in this program, so it'll all be in the same line. Separate output statements don't represent in separate lines of output in the console. If you want to print separate lines of output to the console, let me check my Discord real quick. Turn off sharing bed. All right. So yeah, this one way to output a new line is to output standard inline, which stands for inline. And then we'll cause that cursor to move to the next line. Okay, it's prints. In the web program, the second standard line isn't technically necessary since the program ends immediately afterwards. However, it serves a few useful purposes. First, it helps indicate that the line of output is a complete thought, as opposed to partial output that is completed somewhere later in the code. In this sense, it functions similar to using a period in standard English. Second, it positions the cursor on the next line so that if we later add additional lines of output, for example, have the program say bye, those lines will appear where we expect, rather than appended to the prior line of output. Third, after running an executable from the command line, some operating systems do not output a new line before showing the command prompt again. If our program does not end with the cursor on a new line, the command prompt may appear appended to the prior line of output rather than at the start of a new line as the user would expect. Best practice, output a new line whenever a line of output is completed. Standard character output is buffered. Consider a roller coaster ride at your favorite amusement park. Passengers show up at some variable rate and get in line. Periodically, a train arrives and boards passengers. to maximum capacity of the train, or the train. This analogy is similar to how output is sent to standard cout. Typically processed in C++. Statements in our program request that the output be sent to the console. However, the output is typically not sent to the console immediately. Instead, the requested output gets in line and is stored in a region of memory set aside to collect such requests, called a buffer. Periodically, the buffer is flushed, meaning all the data collected in the buffer is transferred to the destination, and in this case, the console. To use another analogy, flushing a buffer is kind of like flushing a toilet. All of your collected output is transferred to wherever it goes next, you. Also means that if your program crashes, aborts, or is paused, for example, for debugging purposes, before the buffer is flushed, any output still waiting in the buffer will not be displayed. Key insight. The opposite of buffered output is unbuffered output. With unbuffered output, each individual output request is sent directly to the output device. Writing data to a buffer is typically fast, whereas transferring a batch of data to an output device is comparatively slow. Buffering can significantly increase performance by batching multiple output requests together to minimize the number of times output has to be sent to the output device. Standard inline versus new line characters. Using standard inline is often inefficient as actually does two jobs. Outputs a new line, moving the cursor to the next line console, and it flushes the buffer, which is slow. If we output multiple lines of text ending with standard inline, we will get multiple flushes, which is slow and probably unnecessary. When outputting text at the console, we typically don't need to explicitly flush the buffer ourselves. C++'s output system is designed to self-flush periodically, and it's both simpler and more efficient to let it flush itself. To output a new line without flushing the output buffer, we use new line characters inside either single or double quotes, which is a special symbol that the compiler interprets as a new line character. A \n moves the cursor to the next line of the console without causing a flush, so it will technically perform better. \n is also more concise to type and can be embedded into existing double quoted text. Here's an example that uses \n in a few different ways. Single quoted by itself, conventional. Unconventional, but okay. Doing double quotes in existing text, conventional. So yeah, so just don't double quote it if it's not within a string of text already. \n is not being embedded into an existing line of double quoted text. For example, hello. It is conventionally single quoted. For advancers in C++, we use single quotes to represent single characters, such as single quote A or single quote $, and double quotes to represent text, 0 or more characters. Even though quote n quote is represented in source code as 2 symbols, it is treated by the compiler as a single line-fed LF character with ASCII value 10, and thus is conventionally single quoted. Unless embedded into existing double quoted text, we discussed this more in lesson 4.11 talking about chars. When \n is output, the library doing the outputting is responsible for translating the single LF character into the appropriate new line sequence for the given OS. See Wikipedia for more information. Author's notes. Although unconventional, we believe it's fine to use or prefer double quoted \n in standard output statements. This has 2 primary benefits. It's simpler to double quote all outputted text rather than having to determine what should be single quoted, double quoted. More importantly, it helps avoid inadvertent multi-line or multi-character literals. Cover multi-character literals and some of the unexpected output that can be they can cause in lesson 4.11. Single quote should be preferred in a non-output cases. Cover what single quotes \n is in more detail when we get to the lesson on chars. Best practice: prefer \n over standard inline when outputting text at the console. Warning: \n uses a backslash, as do all special characters in C++, not a forward slash. Using a forward slash or including other characters inside the single quote will result in unexpected behavior. For example, the prints 12142, which probably isn't what you were expecting. Okay, so standard character input. Standard character input is another predefined variable in the IO stream library, whereas standard character output prints data to the console using the insertion operator. Provide the data. Standard character input, which stands for character input, reads input from the keyboard. We typically use extraction operators to put the input data in a variable, which can then be used in subsequent statements. So for standard input, standard output, you basically says ask user for a number. It declares a variable called integer x. It doesn't give it a value. or I guess, sorry, defines a variable. I don't know why I keep saying declaring. Defines a variable x, hold user input, and value initialize it. So standard character input, extraction operators. So it extracts the input from inputs inside of x. So whatever number they type in, it'll then put that number within the x variable. Remember keyword stored in the variable x. Standard character output, you entered, prints it out. Try compiling the program running it for yourself. When you use the program, line 5 will print insert number. Code gets to line 8, your program will wait for you to enter input. Once you enter a number and press enter, the number you enter will be assigned to a variable x. Finally, on the line 10, the program will print you entered followed by the number you just entered. Example, entering the value 4 as input, enter number 4, entered 4. Easy way to get the keyboard input from the user, and we will use it many times in our examples going forward. Note that you don't need to output \n when accepting a line of input, as the user will need to press the enter key to have their input accepted, and this will move the cursor to the next line of the code. Your screen closes immediately after entering a number. Please see lesson 0.8 if you common C++ problems for a solution. So your screen will close immediately if you're building it and running it. Oh, let me close this. If you're building and running your program, instead of using it in the Windows debugger, let me pull up. So get project 4, right? So if we're running it here and we just do local Windows debugger and run this, it'll output it, right? And it won't close immediately. But if I were to build it, if I were to go to my open file and Explorer, debug, and run this, it instantly closes, right? Because it's not, I mean, I could just wrap this in a while loop and if I just wrap this in a while loop, it'll print out whatever this value is over and over again. Let me just put a sleep for 10,000. I don't have this. Sleep is undefined. Okay, why don't we know what the fucking, what is the header? Header for sleep C++. Okay, this is what it says is declared in. Okay. Can I open source file for? Let me just see what ChatGPT says about this. What is the header for the sleep function in C++? Oh, am I retarded? I'm not even including Windows.h. Oh my god. Okay, so if we were to let's rebuild this. The fuck? Alright, and we ran this. So it's sleeping for 10 seconds right now, so 10,000 milliseconds. But then it will start. It prints that again, and then again. Let's look at it right now. So it prints it out again, and then yeah. You can do that if you want to be able to see your code or whatever you're doing. It doesn't matter. There's other ways to do it. They showed us early on, like the other earlier videos they showed us. I just can't remember what the fuck it was. Alright. Okay. Values entered should be separated by white spaces. Okay. Just saying you can take the character and put in multiple characters at a time. The answer to the C++ IO library does not provide a way to accept keyboard input without the user having to press enter. If this is something you desire, you have to use a third-party library for console applications. Recommend PD curses, FXT UI, CPP terminal, or non-curses. Standard character input is buffered. In a prior section, we noted the outputting data is actually a two-stage process. Data from each output request is added to the end of an output buffer, and later data from the front of the output buffer is flushed to the output device, the console. Key insight: adding data to the end buffer and removing it from the front of the buffer ensures data is processed in the same order in which it was added, sometimes called FIFO, first in, first out. Similarly, inputting data is also a two-stage process. The individual characters you enter as input are added to the end of an input buffer inside standard character input. Enter key pressed to submit the data is also stored as a \n character. The extraction operator removes characters from the front of the input buffer and converts them to a value that is assigned to the associated variable. This variable can then be used in subsequent statements. Each line of input data in the input buffer is determined by a new line character. We'll demonstrate this using the following program. Enter two numbers, E character input, character output, U entered, okay, return 0. Program inputs two variables, this time as separate statements. I already know what this is, I'm not going to bother reading through this. This is just pretty self-explanatory. You define a variable, and then takes that variable in. You define a variable, it takes it in. So you're gonna need to enter two numbers twice, and then it'll just print out the two numbers that you put in there. Standard character input is buffered because it allows us to separate the ending of an input from the extraction or extractive input. We can enter input and then perform multiple extractions requests on it. The basic extraction process. So my view of how operator extraction works for input. First, leading white spaces, tabs. Okay, why is this thing going so in depth on the extraction operator for standard character input? This is not that, it's not that big of a deal, bro. You just, it extracts any whatever you put into it into the variable that you assign to it. Given the following snippet, okay, if the user types 5a and then enter 5a \n will be added to the buffer, 5 will be extracted, converted as an integer and assigned to variable x. A\n will be left in the input buffer for the next extraction. The following program that we used above. Int main, standard character output, enter number, ask for a number. We define a variable with nothing inside of it. We take the input and stores it within the variable, then we print out the variable. Program expects you to enter an integer variable as the variable of x, and the user input puts an integer variable. Run this program multiple times and describe the output that results when you enter the following types of input. A letter such as h. If we input h, it's just going to give us an error and say that's an invalid. Well, it's not going to say anything because we didn't give anything. It's just not going to work. Result 0 is always printed here. It's just gonna skip this and just return 0 because a number with a fractional part, so it's a floating point number, not gonna work. It's just gonna return 0. Fractional part is dropped. Oh, that's actually a good point. If you input a fractional number, it'll just take the whole number and just drop the fraction. If it were to just hello, this will probably just return 0. Okay, result is 0. A really big number, at least 3 billion. It'll say 3 billion. What's happening, x? You can only hold numbers up to a certain size. You enter a value larger than the largest number x can hold. But it might be different on your system. We discuss this. So yeah, the reason it's saying this is because this is probably a 32-bit integer right here. But if you use a 64-bit integer, it'll be able to store it pretty easily. A small number followed by some letters such as can only take the number. A few letters followed by a small number, it only takes a number. Oh, yeah, I guess it'll return 0. Integer can't hold letters, so extraction completely fails. Okay. +5, 3 spaces followed by a plus symbol and a 5. No idea what that would print out. 5 is printed. What's happening? The leading white space is skipped. Plus is a valid symbol at the start of a number, just as a minus sign would be. It's extracted. The 5 is also extracted. 5, B6. It'll just take 5. 5 is printed. The B6 remains in the future for extraction attempt. Ask the user to enter 3 values. The program should then print these values at an appropriate comment above function main. The program should match the following output when to run the input values. Okay, whatever they wanted to enter 3 numbers, 4, 5, 6. Okay, sure. I'll do this real quick. So this would just be standard character output, enter three numbers. Let's just fucking declare three numbers up here. What am I doing, bro? Int x, y, z. Standard character input. Y, z. Standard character output. X. Space y space z. It didn't work. Initialize local variable x is used. Oh. There are three numbers. Yeah, did I not set this up properly or what? Local variable is not initialized. There's 20 errors? The fuck is this? I mean, bro, to be honest, I can't remember how you fucking set these up. I'm just gonna say int x or int y. Int z. Okay. Enter three numbers, just enter 5. Wait, what? They're not gonna ask me if I thought it would ask me for three numbers at a time. 5. I guess that makes okay, let me just change it up then. Enter a number. Store that as x. Let's copy and paste this. Okay, cool. Alright, there we go. That was like took me longer than I don't even know why that was. Okay. Oh, that's how you do multiple extractions. Oh my god. Okay. Yeah, that's what I did. That's what I should have done right there. Let me just read. Let me put that back in there. Enter three numbers. Okay, cool. All right. Time are we in? 25 minutes. Initialize variables. Okay, this is a pretty easy one. Initialize variables. Unlike some programming languages, C++ does not automatically initialize most variables to a given value, such as 0. When a variable that is not initialized is given a memory address to use to store data, default value of that variable is whatever garbage value happens to already be in that memory address. A variable that has not been given a known value through initialization or assignment is called an uninitialized variable. Nomenclature. Many readers expect the terms initialize, uninitialized to be strict opposites, but they aren't quite. In common language, initialize means the object was provided with an initial value at the point of definition. Uninitialized means the object has not been given a known value yet through any means, including assignment. Therefore, an object that is not initialized but is assigned a value is no longer uninitialized because it's been given a known value. Recap. Initialized, the object is given a known value at the point of definition. Assignment, the object is given a known value beyond the point of definition. Uninitialized, the object has not been given a known value yet. Relatedly, consider this variable definition. So this is uninitialized because it hasn't been assigned anything, or initialized. Before we noted that when no initializer is provided, the variable is defined in a default initialize. In most cases, such as this one, default initialization performs no actual initialization. Thus, we'd say X is uninitialized. We're focused on the outcome. The object has not been given a known value, not the process. As an aside, this lack of initialization is the performance optimization inherited from C. Back when computers were slow, imagine a case where you're going to read in 100,000 values from a file. In this case, you might create 100,000 variables, then fill them with data from the file. If C++ initialized all those variables with default values upon creation, so it would result in 100,000 initializations, which would be slow. Very little benefit since you're overwriting these values anyways. For now, you should always initialize your variables because the cost of doing so is minuscule compared to the benefit. Once you're more comfortable with the language, there may be certain cases where you omit the initialization for optimization purposes. But this should always be done selectively and intentionally. Using the values of uninitialized variables can lead to expected results. Consider the following short program. So we define an integer, we don't initialize it with anything, we print the value of it, but there's nothing to print, so because it's uninitialized, it would be an error. This case computer will assign some unused memory to X. It will then send the value residing in that memory to the standard output, which will print the value interpret as an integer, but what value will it print? Answer is who knows. Answer may or may not change every time you run the program. When the author ran this program in Visual Studio, standard to see output, printed the value 7, 1, whatever the fuck, one time 5, 2, 5, the next. Feel free to compile and run the program yourself. When some compilers use Visual Studio will initialize the contents of memory to some preset value when using a debug build configuration. This will not happen when using a release book configuration. Most modern compilers will attempt to detect if a variable is being used without being given a value. If they are able to detect this, they will generally issue a compile time warning or error. For example, compiling the above program Visual Studio produced the following warning: uninitialized local variable X used. The compiler won't let you compile and run the above program, for example, because it treats the issue as an error. Here is a possible solution to get around this issue. Using uninitialized variables is one of the most common mistakes that novice programmers make. Unfortunately, it can also be one of the most challenging to debug because the program may run fine in any way. Okay, this is the primary reason for the always initialize your variables best practice. Undefined behavior. Using the value from the... Okay, how much longer is this time? Okay. Using the value from an uninitialized variable is our first example for undefined behavior. Undefined behavior, often abbreviated UB, is the result of executing code whose behavior is not well defined by the C++ language. In this case, the C++ language doesn't have any rules determining what happens. You use the value of a variable that has not been given a known value. Consequently, if you actually do this, undefined behavior will result. Code implementing undefined behavior may exhibit any of the following symptoms. Your program produces different results every time it is run. Your program consistently produces the same incorrect result. Program behaves inconsistently, sometimes produces the correct result, sometimes not. Your program seems like it's working but produces incorrect results later in the program. Your program crashes either immediately or later. Okay. Or your code may actually produce like the correct behavior anyway. Undefined behavior is like a box of chocolates, you never know what you're going to get. C++ contains many cases that can result in undefined behavior if you're not too careful. point these out in the future lessons. Whenever we encounter them, take note of where these cases are and make sure you avoid them. Take care to avoid all situations that result in undefined behavior, such as using uninitialized variables. One of the most common types of comment we get from readers says, "You said I couldn't do X, but I did it anyway, and my program works. Why?" The two common answers. The most common answer is that your program is actually exhibiting undefined behavior, but that undefined behavior just happens to be producing the result you want anyways. For now, tomorrow, or on another compiler or machine, it might not. Alternatively, sometimes compiler authors take libraries the language's requirements, when those requirements may be more restricted than needed. For example, implementation defined behavior and unspecified behavior. Specific compiler and the associated standard library it comes with are called implementation, as these are what actually implements the C++ language. In some cases, the C++ language standard allows implementation to determine how some aspect of the language will behave. The compiler can choose a behavior that is efficient for a given platform. Behavior that is defined by the implementation is called implementation defined behavior. Implementation defined behavior must be documented and consistent for a given implementation. Look at a simple example of implementation defined behavior. On most platforms, this will produce 4, but on others, it may produce 2. So size of integer, print how many types of bytes memory. We discussed size of in lesson 4.3. Unspecified behavior, it's also equal to implementation defined behavior in that the behavior is left to implementation to define, but the implementation is not required to document the behavior. Generally want to avoid implementation defined and unspecified behavior, as it means our program may not work as expected, compiled on a different compiler, or even on the same compiler. Change project settings that affect how the implementation behaves. As practice, avoid implementation defined and unspecified behavior whenever possible. It may cause your program to malfunction other implementations. Question 1. What is an uninitialized variable? Why should you avoid using? An uninitialized variable is a variable that hasn't been assigned a value or wasn't initialized with a value when it was first made. Yeah, program generally uses this. Okay, assignment using the okay. What is undefined behavior and what can happen if you do exhibits undefined behavior? So anything can happen with undefined behavior. It's up to, I guess, I don't know, it's up to fucking fate, I guess. And what it is it's when I don't even know how to describe it, to be honest. Let's see what this thing says. Undefined behavior is a result of executing code whose behavior is not well defined by the language. Zero can be almost anything, including something that behaves correctly. Okay, well there you go, you got it. Okay, I'm gonna stop here, bro. I'm toast.